then refrigerator, toaster, vacuum cleaner, washing machine. Okay, so like that, in many domestic goods, we are having fuzzy logic technology. And apart from that, in the environment control, just now I explained one heater, that is room temperature unit. Okay, even AC, air conditioner, we are having fuzzy logic technique. And dryers, heaters, okay, and humidifiers. So for all the electronic goods, mostly we are having fuzzy logic technique. So like that, many applications we can say, but these are the some important area, that is some important application where we are using fuzzy logic. Okay. Then utility of the fuzzy system. Utility, that is we can say the usage of the fuzzy system. Okay. Here based on the several sources have shown and proven that the fuzzy systems are very universal approximator. Okay, many journals and many articles are there. So based on the sources, we can say the fuzzy systems are a universal approximator. What is the universal approximator? That means it can hold any number of inputs and outputs. Okay, so not like a binary logic or not like a binary system. It can handle any number of inputs and outputs. That is the speciality of the fuzzy system. Okay, so by this proof, the from the isomorphism between two algebra, here I mentioned linear algebra and abstract algebra. Okay, if you take an abstract algebra, that means one dealing with the groups, fields, and rings. I think these are the topics you studied in discrete mathematics concept. Okay, so in the abstract algebra is meaning with dealing groups, fields, and rings, and a linear algebra, one dealing with the vector spaces, state vectors, and transition matrices. Okay, uh, and the structure of the fuzzy system, which compromises or which comprises an implication between action and conclusion. That means here I mentioned antecedent and consequence. Okay. Generally, the structure of the fuzzy system comprises an implication between action and a conclusion. So, we have to take some action based on the conclusion. So that's what we are telling antecedent and consequence. So based on these two category, so based on these two input, the structure of the fuzzy system will be formed. Then, if you take an algebra, okay, so in the algebra and a fuzzy system involves a mapping between the elements of two or more domains. Okay, here just as an algebraic function, here maps an input variable to an output variable. Okay, here based on the input only, we are getting the output. So a fuzzy system maps an input group to an output group. That's what we are relating with the algebra. So in the later, so these groups can be linguistic proposition. Okay, or we can say other form of fuzzy information. So in the other form of fuzzy information. Okay, here the fuzzy system contains uh, all, that is all of what algebra has to offer. See, whatever the facility we are having with algebra, So mostly the linear algebra and abstract algebra provides many facility. So apart from that, okay, uh, apart from that, the fuzzy system can handle all kinds of information. Okay, not only in the numerical quantity. Okay, not only in the numerical quantity. So upon algebraic concept, the fuzzy system provides or can handle more kinds of information, not only the numerical value. That's what I told you. The previous system, generally, if you take the algebraic system, can handle only true or false. Okay, true or false information. But but a fuzzy system can handle more kind of information apart from true or false. That's what I told you. In between yes or no, we can include more options also. Okay, that is uncertainty of input. Then uh, rather the primary benefit of the fuzzy system theory is to approximate system behavior, okay, where the analytical function or the numerical relation does not exist. That's what I told you. Apart from the numerical quantity, not only the numerical relation, the fuzzy system can handle more than that also. So that kind of system is called a complex system. Okay, we are telling that complex system. That means complex system can be a new system. What is meant by complex system generally? So the complex system, how that is complex system is a new system that have not been tested at all. Okay, so they can be system involved with the human condition. Generally, if you take a uh, uh, computer system can handle only the defined input. That means binary input. That is either one or zero. Okay. Here, if you take the complex system involved with the human condition, that is the biological or medical system input also we can handle. Okay. That means some behavior of the human input also we can consider for the solution. Okay. Yeah, that's what the human condition, such as biological or medical system, or they can be social, economic, or political system, where the vast array of input and output could not all possibly be captured or analytically or controlled in any conventional sense. Okay, that's what I told you. uh, the complex system, we are getting the input from many ways. It may be the human condition like biological or medical system, or in sometimes we are getting the input from social, economic, or political systems also. And apart from that, we are getting vast array of input and corresponding output possibly captured from analytically are controlled in any conventional sense. Okay, controlled in any conventional sense. Moreover, the relationship between the causes and effects of the system is generally not understand. That is the main scenario here. But, we cannot understand exactly what the system will do, but we can observe the system. Okay, often we can observe the system. Okay, so alternatively, the fuzzy system theory can have utility in assessing some of our more conventional, less complex system also. Okay, so not only in the complex system, in alternate way, the fuzzy system theory can handle a conventional and a less complex system also. Say for example, uh, some problems, okay, some problems may have exact solution. Exact solution, uh, and sometimes some problem have exact solution are not always necessary. Okay, so like that, many kinds of problems are there. Okay, some problem we need exact solution. Sometimes some problem there is no exact solution. It is always not necessary. Okay, but an approximate but fast solution can be useful in making preliminary and design decision. Okay, design decision. But sometimes by using the fast solution, we can make a preliminary design of the particular decision, or an initial estimate in a more accurate, that is the numerical techniques to save the computational cost. Is another way. Okay. So in the previous scenario, we are not getting the accurate solution, that is the exact solution. Some system is not necessary to get the exact solution, but uh, some system is more accurate numerical technique to save the computational cost. That is, if you are giving the exact input, okay, so we don't want to spend more cost for computation. That means it may take less time to compute the output. Okay, that's what they are telling. We can save the computational cost. Okay, but in many situations uh, where the inputs to a problems are vague, that's what the fuzzy system coming into the picture. Okay, if the inputs are vague, are ambiguous, or not known at all, there is not known in the sense there is no clear input. Okay, blurred. That's what I told you yesterday. Blurred, or vague, or ambiguous. So whatever the word you want to use, you can use. Okay. So in some situation, the inputs to a problems are vague, ambiguous, or not known at all. So in this case, the fuzzy system will be helpful. Okay. Say for example, suppose we need to control the aircraft. Okay. In the aircraft control, that is, suppose the aircraft want to drive the vertical drive, or vertically if you want to drive. So by using the conventional controller, okay. See, I'm talking about the aircraft controlling. The aircraft is flying. Then just assume that if you want to control the aircraft to drive in the vertical direction, vertically, so the conventional controller cannot handle this scenario. Okay, the conventional controller in the sense I told you, no, that is the binary logic. By using that logic, we cannot control. But as they are restricted to linear range, why the conventional controller cannot handle this situation? Because they are restricted to linear ranges of variables. Okay, only the linear data we are having. So a dive situation is highly non-linear, but the scenario is different. Vertical dive, okay, vertical dive we have to do, but in this dive situation, by using the linear ranges of value, we cannot control. So the conventional system can control only with the linear data. So this is not possible with the conventional controller. Okay. So because the dive situation is highly non-linear in nature. Okay. So in this case, what we have to do? So we could use the fuzzy controller only. Okay, so the conventional control logic will not work here. So the fuzzy controller, which is adept at handling the non-linear situation, non-linear situation. Hence, the fuzzy system are very useful. Okay, to handle the non-linear